You know the feeling. You have done a massive stoichiometry calculation in your IGCSE examination. You have used number of moles is equal to mass upon mR. You did find the ratio. You did got an answer. But when the results come back, you have lost 1 mark. Why? The mistake isn't the math. The mistake is how you are laying it out on your paper. Most schools teach you the formula, but they forget to teach you the scaffold method that the examiner actually want to see. Today, I'm going to show you that one trick that makes it really impossible to lose marks, even if your final math has turned out to be wrong. Most students treat the exam paper like a scratch pad. They calculate the mass of some substance A, then they calculate the moles, then they have found the ratio in their head, and then they calculate the mass of the another substance, and then somewhere they have actually lost the marks. Stop doing this. The IGCSE mark scheme is built on step by step logic. If the examiner can't find the mole ratio, they cannot give you the method mark, even if your final answer is slightly off. The secret: stop thinking in formulas and start applying and thinking in the 3-line rule. Let's understand that. We have the example question from the past paper. We have to calculate the mass of the Fe produced from 80 gram of iron 3 oxide reacting with the carbon monoxide. Here we can simply see that the equation which is balanced is given to us already. We have the molecular mass of iron 3 oxide and we have the atomic mass of Fe. Now, whenever you see such kind of stoichiometric question, we have to draw 3 rows under the balanced equation. First, what is known to us. Second, very important, the mole, and what the question has asked is the target. Now, what is known to us is the mass given of iron 3 oxide, that is 80 grams. They have also given us the MR, that is 160. We can simply find out the mole of Fe2O3 by putting down into the formula. Number of moles is equal to the mass upon MR, that is 80 upon 160. When you apply this on the calculator, you will simply find the answer as 0.5 mole. Now, let's get back to the other part. They have asked you to calculate the mass of the Fe produced. Now we know is such kind of question, we have to use the concept of something called as mole ratio. Now we have found out the mole for Fe2O3 and we have to find out the mass for Fe. Now with the help of mole ratio, I can simply find out the mole of Fe. Now this is where the student make a lot of mistake. If you look at the mole ratio which student do in their head, which is absolutely wrong. You have to actually note it down on the paper because this is what the examiner is looking for in your step-by-step method. The ratio for mole is to Fe, for Fe2O3 to Fe is 1:2. So very simply, if you put it down, for Fe2O3 we have got 0.5. For Fe, we have to simply multiply it by 2. So 0.5 into 2, and we have got the number of moles for Fe as 1 mole. But the question says we have to find out or calculate the mass of Fe. We will use the same formula for the number of moles, but we have to tweak it. The mass of Fe is equal to my number of moles which I have got into the MR or the atomic mass. So 1.0 into 56 and I will get my final answer as 56. So here I have simply gained and I have actually wrote it down in the step-by-step method by putting down all the formulas, and I've actually written the mole ratio for the examiner to understand and allocate me the full marks as per the mark scheme. So I hope you have understood it with the help of an example that stoichiometry isn't about just being good at math. It's about how you being a good architect. Build the structure, Write each and everything in step-by-step method, and hence the examiner will never get a chance to even deduct a single marks of yours in the theory paper. See you in the next video. Bye.